This is section 2.2, day 2. Find a polynomial function of degree n with only the following real zeros. More than one answer is possible. Number 1, we have the real zeros -2 and 3, and n is equal to 3. So we need a polynomial of degree 3 with these two zeros. Now there's only two zeros listed, and we need 3 total zeros. Either I'll have to count this zero twice or this zero twice. So the polynomial f of x is going to be equal to x plus 2 squared times x minus 3. Now I can either put the squared on the x plus 2 or put the squared on the x minus 3. Zeros are the values that make the factors 0, and that's why we need x plus 2. -2 makes x plus 2 0, and positive 3 makes x minus 3 0. Now we just have to work a little algebra on this and get what the polynomial is. So this is x plus 2 times x plus 2, which is x squared, plus 4x plus 4, which is the old FOIL technique, and then times x minus 3. To multiply out the rest, I'm going to use the distributive property twice. So I'll distribute the x through, and then distribute the -3 through, and then collect like terms. So we have x to the third plus 4x squared plus 4x. So there's distributing the x through. Now we distribute the -3 through. So we have -3x squared minus 12x, and then minus 12. So the polynomial is f of x equals x to the third plus 4 minus 3 is 1, so we have x squared, minus 8x, and minus 12. In the second one, we have 0, -1, and 4 as the zeros. There are 3 zeros, but we need 4 zeros. We need a degree of 4. And the easiest way to get 4 zeros using these 3 is to count the 0 twice. So we have f of x is equal to x squared. There's counting the 0 twice, times x plus 1, and then times x minus 4. Now instead of, I don't really want to distribute the x squared through, I want to FOIL these two together. So we have x squared times x squared minus 3x minus 4, and that's old FOIL, first, outside, inside, and then last. And then now we just have to distribute the x squared through, which is x to the fourth minus 3x to the third, and then minus 4x squared. Determine whether the degree n of the polynomial for each graph is even or odd, and whether its leading coefficient a sub n is positive or negative. Let's do a little bit of review. If we have x squareds look like that on the end. Negative x squareds is x squared upside down. Then we have x to the third, looks like that, and negative x to the third looks like this, very close to that. So this one, let's see, what does it say? Determine whether the degree n is even or odd. This one has to be even, and then is the leading coefficient positive or negative, and this would be positive. This one looks like a negative x to the third in how it finishes. So this would be odd for the leading power. And then this one would be negative for the leading coefficient. They would be negative. It looks like a negative x to the third on the ends. This one, it would be even. It looks like a negative x squared on the ends. So even and then negative. This one looks a lot like an x to the third. So we have an odd power, and that leading coefficient on this one would be positive. Determine a polynomial function then that has each set of zeros. More than one answer is possible. When we have fractions, we really don't want x minus 1/2. I don't want to deal with these fractions. There's another way to write a factor that has a zero that is a fraction. If we had 2x minus 1 set equal to 0, and then we solve that for 0. We would add 1, and then we would divide by 2, so that'd be 1/2. If it's 2x minus 1, then the 0 would be 1/2. So this function, f of x, is equal to 2x minus 1. That would give me a 0 of 1/2, because I would add the 1 and divide by 2, times 4x minus 3. In this case, we would add the 3 over and then divide by 4, giving us a 0 of 3/4. And then x minus 2 and x plus 3. To complete this, I'll have to FOIL these two together and FOIL these two together, which we will get 8x squared. I have negative 6 and negative 4, that's negative 10x. And then negative 1 times negative 3 is plus 3. And then when we FOIL these two together, we get x squared plus x minus 6. Now to finish this, I'll distribute the 8x squared through, the negative 10x through, and the 3 through. So we get 8x squared through, which is 8x to the 4th plus 8x to the 3rd minus 48x squared. I'll distribute the negative 10 through. We'll get negative 10x to the 3rd minus 10x squared, and then plus 60x. And then finally, multiply the 3 through, gives us 3x squared plus 3x minus 18. And now we just have to collect like terms. F of x is equal to, we have 8x to the 4th minus 2x to the 3rd. Let's see, negative 58, negative 55x squared plus 63x, and then minus 18. For each of the following graphs, A, determine the least possible degree in n behavior. This, at the very least, has a 0 once, and then here at the very least a 0 twice. When a function crosses the x-axis, that means this 0 counts an odd amount of times. So this 0 could count once, 3 times, 5 times, 7 times, and so on. When the graph just touches the x-axis and then goes back down, or touches and comes back up, that means this 0 counts an even amount of times. When we have an odd amount of zeros, they cut through. When we have an even amount of zeros, we say they bounce off the x-axis. So this 0 could count twice, 4 times, it could count 6 times. So we could have a power of 13 possibly, this one counting 7 times and this one counting 6. But they want the least possible degree, which means we would have a power of 1 here, the 0 would count once, and the 0 would count twice for 3. So letter A, the least possible degree is 3. And then we have the n behavior. The limit as x approaches negative infinity of the function is positive infinity. So as x goes to negative infinity, y is going to positive infinity. And the limit as x approaches positive infinity of f of x is equal to negative infinity. So there's the ending behavior. Let's get rid of this, clean it up a little bit. And we need letter B. Locate the zeros and their multiplicity. So here's 1 0 at negative 2, and we're assuming all zeros are integral values or integers. So the first 0 is x equals negative 2, and the multiplicity is 1. Then we have x equals 3, and the multiplicity at the very least is 2. Letter C, create a function that fits the graph and the given point. In letter C, we create a function that fits the graph and given point. The given graph has zeros at negative 2, which is going to count once, and zeros at 3, which we count twice. So in letter C, f of x is equal to k times x plus 2 times x minus 3 squared. And we need the k so that we can get this graph to pass through the point negative 1, negative 8 and have the zeros that are given here on the graph. To find out what the constant is going to be, let's plug negative 8 in for f of x because it's the y value. We have negative 8 is equal to k times, and then we're going to plug negative 1 in for the x values. We have negative 1 plus 2 times negative 1 minus 3 squared. Negative 8 is equal to k times, this will be 1 times, and then we have negative 4 squared. Negative 8 is equal to k times 16, and then we divide by 16, so k turns out to be negative 1/2. F of x is equal to negative 1/2 times x plus 2 times x minus 3 squared, and then we have a little bit of algebra to do. We have negative 1/2 times x plus 2 times x squared minus 6x plus 9. F of x is equal to negative 1/2 times, we have x to the third minus 6x squared plus 9x, and then we have 2x squared plus 12x plus 18. F of x is equal to negative 1/2 x to the third. We have negative 6 plus 2, which is negative 4, and half of that is going to be plus 2x squared. And then we have 9 plus 12 is 21, so we have minus 21 over 2x, and then finally minus 9.